Hello friends, welcome to another chemistry video from eLearn. My name is Timen and I'm a chemistry tutor at eLearn. In this video, we will discuss 3 past examination questions on electrolysis. We will focus on question analysis in terms of topic words and command words, and I'll give model answers for the questions. Here, the topic words will be obvious because we already know the topic. In the exam, you will not have this luxury. 3 questions we will discuss are from Cambridge IGCSE and O-Level and NSSC O-Level. With much further ado, let's delve into it. So we are going to start with the Cambridge IGCSE 0620 paper 4 question. It's from the year 2020. So when we look at the question, the main words that we want to look at as we analyze the question are the words that we call the topic questions and the command questions. Now, the topic questions are telling you what the question is about or the topic that is being tested. Now, in this case, we know this is about electrolysis. And when you read this question already, you can see that they throw in electrolysis somewhere so that you know exactly what topics it is about. Like when they introduce the question, dilute sulfuric acid is electrolyzed, there is the topic word electrolyzed. And then we still have the topic word again in part 1 of the question, electrolysis, and then we have the command word. So the command word in this question is state. Now, what does state mean? They want you to give a very short answer to the question. And electrolysis, in this case, is the topic word. So here we are being asked to state the meaning of the term electrolysis. Now, when you combine everything, this will look more like define. Now, how do we know that? We look at the mark allocation. They are giving 2 marks for this question. Therefore, we really need to give 2 points. So what are the 2 points they are looking for? First part is breakdown of an ionic compound in molten or aqueous state. The next part is by passage of electricity. Now, when examiners award marks, they can change the allocation that I've shown you here. You might be in a case where they'll say, for the first mark, it's breakdown by passage of electricity, and the second mark is of an ionic compound in molten or aqueous state. So examiners do this. At times they change how they give the marks. Like we're looking at here, they could be giving for breakdown of an ionic compound in molten or aqueous state for 1 mark, and by passage of electricity for the second mark. Or they could give breakdown by passage of electricity of an ionic compound in molten or aqueous state. The advantage that we have here is it's a definition, and you have to really give all the details. So let's move on to the second part of the question. The second part, our command word is explain. We can take that as the topic word or phrase here is inert electrodes. Now, what does explain mean? They are looking for a reason. So whenever you are asked to explain, they are simply saying, give us a reason why. And then the mark allocation here is 1. So it means you're not really required to give a lot. Just 1 reason will be sufficient. So what is it they want? they want you to explain why inert electrodes are used. The answer there is straightforward. It is because the electrodes do not react with the electrode products or electrolyte. You'd find for this question, they could have given the mark for simply saying electrodes do not react. I've used electrodes here to avoid using pronouns. This is one thing that you'll have to learn in exams. Avoid making use of pronouns. Just use the noun itself. Let's move on to Roman 3. We've been asked to name, and we've been asked to give the name of the products formed at each electrode. Now, what's important here is they are looking for the names. Now, what happens if you give the chemical formula, like for hydrogen, which is the product at the negative electrode, H2? You may get the mark or you may not. So if they say name, they're really looking for the name. You have to give the name in full. So at the negative electrode, which you will understand is the cathode, we produce hydrogen. And at the positive electrode, which is the anode, we produce oxygen and water. So examiners in this case will give you the mark for oxygen without giving the water as well. But we understand that these are produced at the positive electrode, both of them, but the focus is usually just on the oxygen. We move on to the next one. Here we are required to write, what are we writing? An ionic half equation. Now, the ionic half equation should always be balanced. And where is the ionic half equation? Is for the reaction that's happening at the negative electrode, and the negative electrode is the cathode. How many marks are we being given for this? We're being given 2 marks. So in general, we are going to have 1 mark for the substances and the second mark for balancing. So here is the equation. The 2H plus receive the 2 electrons, and then we get hydrogen. Now, when you look at the way that I'm giving the answers, is I'm writing my answers on the line, and I'm making sure that everything is clear, and whoever is looking at the work can read and see exactly what you're putting across. This is something that is expected of you. Good handwriting pays in exams, because if an examiner cannot read what you have put down, they will not give you the mark. If they can't see, they can't see. Okay, let's move on to the O-level question. It's from the year 2023. And in this case, they have really given us the topic word right at the top. They tell us this question is about electrolysis. So there you have the topic question. There's more information. They tell us we have 3 different electrolytes. And what do they want you to do? There is the command word. They want you to complete table 8.1. Now, what's important here is you have to give the names. Again, they want the names of the products at each electrode. You are going to be very careful when you give your answers. They have 3 marks for 6 points, or for 6 names, which means half a mark for each one, or they could say all correct is 3 marks, 4, 5 gives you 2 marks. Anything above 3 or 4 will give you 1 mark, and anything below that will give you 0. So examiners will make decisions how to give the marks, and it's your job to make sure that you put everything on the paper. Now, when we give answers to these questions, you've got to be very careful that you see the anode and the cathode, and you realize the anode is the positive side and the cathode is the negative side. Now, what happens if you make a mistake and you consistently put cathode products under the column for product at anode, and anode products under the column for product at cathode? You may lose all 3 marks. You may not get anything. So be very careful, check exactly anode, use acronyms or mnemonics to be 100% sure that you're getting the correct answer. So let's start. We're looking at concentrated aqueous potassium iodide being electrolyzed. What do we form at the anode? Remember, the anode is the positive electrode, iodide ions and hydroxide ions go there for a competition. The competition here is won by the iodide, and iodine is produced. Now, why is iodide winning? Because they are present in higher concentration. What do we produce at the cathode? There we are going to have potassium ions and hydrogen ions. Now we know that potassium ions are never discharged from aqueous solution. Therefore, we are going to produce hydrogen. Dilute sulfuric acid product at the anode is going to be oxygen, you might want to say, and water. Hydroxide ions and sulfate ions go to the anode. The hydroxide ion is the one that is discharged. Sulfate ions are never discharged from aqueous solution. And at the product, again, we produce hydrogen. Here, there is no competition. We only have H+ ions. Molten lead-2 bromide. What do we produce at the anode? We produce bromine. Okay, there is only one ion there because it's molten. And then at the cathode, we're going to produce lead. I'm going to talk about a few problems that you will see in exams. The first one is not changing the anode product from the ion. So if you give your answer as iodide, you don't get anything. Bromide, you don't get anything. The other problem at the cathode is lead-2. If you give your answer as lead-2, there is no mark for you there. Okay, we move on to the next question. Give 2 reasons why graphite is a suitable material from which to make electrodes. So they want 2 reasons. Supposed to give 2. All right. And here we are saying suitable. It's what we're focusing on. The first part is that the graphite is unreactive, which is exactly the same thing as saying it is inert, which means in this context, the same thing as saying insoluble. So if you give these 3 or 2 of these as 1 and 2, you will only get 1 mark. For instance, if the first one is unreactive and the second one is insoluble, the only mark that you get there is 1 because you're repeating the same point. The second possible answer that you could give here is conducts electricity. That is the second point. You could say graphite is a good conductor of electricity. Means the same thing. Now there is an extra point that we can give here, which is point number 3. In my case, high melting point. But now that I've brought this idea of giving more than the required, you need to remember that if the third one that you give, where you're required to give 2, and the third is incorrect and contradicts any of the previous 2 answers that you've given, the mark will be taken. For instance, you say unreactive for point number 1, conducts electricity for point number 2, soluble in the electrolyte for point number 3, you will only get 1 mark because the third one is incorrect, soluble in the electrolyte, and kind of contradicts your initial number 1, unreactive. So you only get 1 mark there. So my advice to you is when you are asked to give 2 reasons, you give 2 reasons. You choose the best ones that you can think of and you just give 2. Don't try to be clever and give more than what is required. Just give what is required and avoid direct contradictions, which examiners always penalize. We got to see more or less the same thing. What are we required to do? Required to construct half ionic equations for the electrode reaction that they have described. The electrode reactions is happening at the anode, and they tell you oxide ions react to make oxygen molecules. So because they have described everything there, they are giving you only 1 mark. So here is our balanced equation. O2 minus forms oxygen, and 4 electrons are given away. Okay, so let's move forward. We're going to the NSSCO level 6117. I think this one is another 2020 paper. The same thing is happening, electrolysis of molten lead to bromide, which is topic words or the topic phrase that tells us what the topic is about. Our first question here requires us to explain. Remember, explain is asking you to give a reason and why solid lead to bromide does not conduct electricity when molten is a good conductor. Okay, so the issue here is solid does not conduct electricity, but the molten conducts electricity. You're just giving 1 mark, which means it's not much that you have to write there. So our answer, in solid lead to bromide, the ions cannot move. So I have emphasized that I'm talking about the solid phase, and I'm saying the ions are not free to move. So it should be clear, and this is why I said avoid the use of pronouns, because at times when you use pronouns, it becomes unclear whether you're talking about solid or you're talking about molten. So just tell us if solid led to bromide rather than it or they. All right, let's go on to B. Results of 3 electrolysis experiments. There is your topic word, electrolysis. The command word comes in, complete the table. So we are going to complete the table. We identify the product. Now, I like identify because when they ask you to identify, you can use the name or you can use the formula. So the advantage of identify is if you use the name, you get the mark. If you use the formula, you also get the mark. Okay, so let's go into it. And they are giving 4 marks. So the good thing here is each one will have its own standalone mark. So what are we looking at? Experiment 2. Aqueous copper 2 sulfate is the electrolyte. We are using copper electrodes. And they are asking us for the product at the cathode, which is the negative plate. And this is where we form copper. And then what do we produce at the anode? At the anode, we produce the copper 2 ions. Remember, we are using copper electrodes, which means that the copper is going to dissolve into the solution. Although we have the hydroxide ions and the sulfate ions going to the anode, none of them are discharged, but instead copper is oxidized. So we're going to produce copper 2 ions. Okay, so let's go to experiment 3. In experiment 3, our electrolyte is aqueous sodium chloride, which is concentrated, and we are using carbon electrodes, which means they are inert. So what do we produce at the cathode? 2 ions that go to the cathode, sodium ions and hydrogen ions, and the hydrogen ions are preferentially discharged. Remember, sodium ions are never discharged from aqueous solution. So what do we produce at the cathode? We are going to produce hydrogen. And then we go to the product at the anode. 2 ions are going to drift to the anode, which are the hydroxide ion and the chloride ions. The chloride ions are preferentially discharged because they are present in a higher concentration. So we produce chlorine at the anode. Now, the good thing with this question is that the examiner provides a further information to help you come up with the correct answer, which is the change to the electrolyte. So when you look at experiment 2, you realize that the electrolyte does not change, which basically tells us that none of the ions in solution are actually discharged. So this means that the copper ions in the solution remain, the hydrogen ions in the solution remain in solution, the hydroxide ions in the solution remains in solution, and the sulfate ions remain in the solution. None of those are discharged. So what essentially happens is that copper is transferred from the anode to the cathode by forming copper ions at the anode and discharging those same copper ions at the cathode. And for experiment 3, we are told that the electrolyte changes to sodium hydroxide. And this simply tells us that sodium ions are not discharged at the cathode. We produce hydrogen, and hydroxide ions are not discharged at the anode. We produce chlorine. So these are the simple questions that I want you to go through. And this is kind of the standard way they ask you these questions. Thank you so much for watching. Where do we go from here? You have to like the video, subscribe to my channel, click on the notification bell so that when I produce another video, you will not miss it, and I'm going to be producing a few more. And what else do you want to do? You want to share this video. Thank you so much. Bye-bye for now.